Okay, so the last video cut out actually mysteriously. I think there was a problem with connection. So we're going to go through just question 15 on this video. All right, so I've already done some highlighting here. We're starting with Farmer Wright has 240 feet of fencing and he wants to build a rectangular fence. Okay, we've seen this kind of setup before. He wants to build a fence alongside of a river. So we're only going to form 3 sides of the rectangle with our fencing, as the river will form the 4th side. What are the dimensions of the rectangle that will make the maximum area for Mr. Farmer Wright's cows? All right, so I drew a little diagram here before the camera disconnected. As I'm sure you'll agree that so these deep lines, those represent the fencing that Farmer Wright will actually build, and the river here is, well, that's something he doesn't. That's just going to be a natural barrier for cows. They're not going to enter the river, so they're just going to stay within this confines. All right, and I started making a little example here to just kind of dig my teeth into this problem a little bit and see if I can get a feel, an intuitive feel for what's happening here. All right, so I know that I made an example, so I could say, well, maybe the length here of this side would be 20 feet. That'd be 20 feet over here as well. And if I wanted to know how long it is on this side of the fence, so that overall we're adding up to 240 feet of fencing, I would say I'd take away 240, take away, I could take away 20, and then take away 20 again, or I could take away 2 20s. And then I get the number 200. 200 feet. So that's one possibility. 20 plus 200 plus 20, that's 240. All right. Another example, just so I can get the feel for it, make sure I'm doing the same thing every time. I could say maybe this is going to be 50 feet. And that's going to be 50 feet. And then what am I going to have left over here? How much is this going to be? Well, I'm probably going to do the same thing again, 240, and I'm going to take away, I'm going to take away 2 20s anymore. I'm going to take away 2 50s. So the only thing I really am going to change is that's going to be a 50. And it tells me this must be 140 feet. Okay. So what do I have here? I've got step 1, I've got a diagram. And I'm going to label that diagram. So what I want to say is, okay, I'm going to say that side could have length x. And the question of, well, what goes here? Well, it turns out that whatever number that is, it's usually the length of the total fencing I have, 240, take away 2 times whatever my side length is, which in this case is 50, in this case was 20. In this case, it's just x. I'm going to say this is 240, take away 2 x's. Okay, so I'm going to move on from that. I'm going to say, okay, well, we want to maximize area. So step 2 is we're going to want an area equation. All right, now we know area for any rectangle is length times width. So it means x times this width, 240, take away 2x. Okay. Now, step 3 is, well, I could graph that in Desmos, and I could take a look at Desmos, the parabola. And if I do that, okay, well, what would I even be looking at if I did that? Well, my x values, they represent side lengths, right? And that's x. However, on my y-axis, I'm actually measuring area. So it's A for area. Okay. And when I graph this, I get a parabola that looks something like this. Yours may look a little skinnier in Desmos. And there will be a vertex here. And that it'll hit at 0, 0, and it'll hit at, give me a second, it must be 120 and 0. And this guy must be 60 and 0. Okay. And these might represent all the different areas you could get when you put in a certain length of side. And so, okay, imagine if I put in, say, a 20-foot side, that'd be here. That'd be the point 20. And the area here would be 20 times 400, so that'd be 4. Oh, wait, sorry, that's not 60 and 0. That's got to be 60 and, sorry, 60 times 120? Oh, 60, 60, 7,200. And that's 4 here. So it'll be 20 and 4,000. That's one possible combination of side lengths that we've got here. However, the area of this one is 50 times 140, or 7,000. So if I choose 50, I end up with a point here, and that point is at 57,000. However, that's not the maximum area I could get. The dimensions of the fence that are ideal, maximal, optimal, are at the vertex. So the vertex is at 60 and 7,200. So that says the maximum area will be 7,200 if the dimensions chosen are a width of 60 feet, and a length of, well, what would I have left? I'd actually have to go back to my original equation to calculate what the dimension of this one would be. These guys are 60 and 60. I'll draw that up, 60 and 60. And this length is going to be, well, it's going to be 240. Take away 2 times 60. That predicts the length of that side, which is 120. 120 feet. And those are the dimensions, oops, pardon me. Those are the dimensions that give us our maximum value. Maximum area, 7,200 square feet.